In this part of the lesson, we're going to look at multiplying fractions using a partial products method. And so what I want to begin with is maybe you're not familiar with partial products. Maybe you were taught a traditional algorithm or some other algorithm. So I want to take a look real quick at partial products and what that means. Okay, and here's what it means. So say we've got a problem like 36 times 55. Okay, and so lots of different ways we could multiply that, but in a partial products, what we do is we take each place value and multiply it by the other place values. And here's what I mean. So we're going to take the ones, and we take the 5 times 6, and that gives us 30. So we've done the ones, but we don't just have 5 6s, we have 5 30s and 5 6s. So we're going to take 5 times 30, and that gives us 150. So what we've done is basically we're taking these numbers and we're expanding them, making that 30 plus 6, and we're going to make this 50 plus 5. Okay, so then now we're going to multiply by the other 5 here, and that's 5 in the tens place times 6 in the ones place, so we're multiplying across this way, and we get another 30, but it's 30 tens, so it's actually 300. And here we're multiplying 5 tens times 3 tens. 5 times 3 is 15, but since they're both in the tens place, we would add another 2 zeros to that, and we get 1500. And then when we add all these numbers together, we get the total value here. Okay, so there's 8, there's 9, so it looks like our answer is 1,980. And where this comes from, and really where all multiplication can be traced back to, is an area model. And I'm going to show you that right here. So when we've taken these two numbers apart, okay, we've got 6 times 50, because we're going to find the area of each space, and that's going to tell us the total area inside this diagram, which will give us the answer to a multiplication problem. So let's do this first. 6 times 50, okay, that's 300. 30 times 50, that's 1500. 5 times 30 is 150, and 5 times 6 is 30. And if you look at these four numbers here, okay, there's our 30, there's our 150, there's our 300, and there's our 1500. So that's what an area model looks like in multiplication. And one of the things that I want to point out about this, and the reason I'm doing this, is because we just can't, when we multiply 36 times 55, we can't just do 5 times 6 equals 30, and 50 times 30 equals 1500, and expect that to come up with the right answer. It doesn't work. We have to cross multiply as well. Okay? So let's look at this method with an area model for fractions. Okay, so we're going to start out the same way. So I want you to go ahead and diagram 4.5 by 2.5 and create your rectangle, but don't fill anything in, just create your rectangle and stop right there. Please do that now. Okay, so hopefully your model looks like this one. I've counted each space as 1/2, so that makes 1, that makes 2, that makes 3, that makes 4, 4.5. This makes 1, 2, 2.5. So this is 4.5 by 2.5, and that will give us, if we figure out the area of this piece, that will give us the total area or the answer to the multiplication problem. Only this time, instead of counting up the total number of squares, I'm going to divide this into its parts. Okay, and what I mean by that is from here to here, I have the first part of that number. I have the 4. 2 is 1, so 2 more is 2, 2 more is 3. Oh, should have gone one farther. Let's go ahead and do that. So there we have the 4. And let's do this with a different color. And this is going to represent the 1/2 right here. Okay, So as I draw a line here, I'm just going to stop. Well, I'll go all the way down. Okay, so this represents 4 across. Okay, and this represents the 1/2. And I'm going to do the same thing going the other way. So now from here to here, I have my 2, and underneath it, I have my 1/2. So let's create that box. Now, just as in the other model, okay, if I can figure out the size of each of these boxes within the rectangle, since there's no open spaces here, if I can figure out the dimensions of each of these boxes, add them together, then I would have the total in the box, which would be the answer to my multiplication problem. So this one here, this box, okay, we'll go with green here, from here to here, okay, everything inside this box, I know it is 4 by 2, so I know the volume of this box here is 8. And I'm going to record this piece right here. 4 times 2 is 8. Okay, let's pick another box here, box underneath it. Okay, how big is this box? Well, this rectangle is 4 by 1/2. So 4 times 1/2 is simply 4/2. Could say 2, but I'm going to record it as 4/2. Okay, now let's go to another one. Let's do this one right here. Okay, how big is this rectangle? Well, it's 2 down, and it's 1/2 across. So let's record that. 2 times 1/2, and that is equal to 2/2, or 1/2. And then lastly, we have this box remaining. And so the size of that is simply 1/2 by 1/2. And that is equal to 1/4. Okay. Now in this case, since we've used common denominators, we only have one fraction that has a different denominator than these two. So this is fairly simple for us to add up. But the pieces that we need to put together are 8 plus 4 over 2 plus 2 over 2 plus 1 over 4. I'm going to go ahead and give these a common denominator of 4. And that's one of the nice things about this. You will always find your common denominator in that lower box, even if there are different denominators for these two numbers. Okay, so there's still 8 wholes, 4 over 2. If I multiply that times 2 over 2, okay, anytime I multiply a number by 1, I do not change the value. So I'm simply multiplying this by 1 to get a denominator, desired denominator of 4, and that gives me 8 over 2. Same thing over here. Gives me 4 over 2. And this one just stays, oops, those are denominators of 4, not 2. And this one becomes 1/4, and it stays 1/4. Okay. And now I can add this up. I have 8, 12, 13 fourths. And I have 8 in the whole column. But I can change this to a mixed number. 13 fourths is 3 and 1/4. And so my final answer is 11 and 1/4. Okay? So that's what using an area model looks like with a multiplication problem of mixed numbers. So here's my next problem. And what I'm going to do is I'm going to streamline this process a little bit because from here what I want to do is just show you some different ways that you can solve this without having to go through the process of drawing out the graph every time. Okay, the graph is just there so we get that basic understanding, but now we're going to streamline it. And there's 3 ways we can streamline this process. Okay, and the first one is simply to use a graphic organizer. Okay, so we've got 2 numbers, and we're going to break them into 2 parts each. So here we have a mixed number of 3 2/3. So that's 3 plus 2/3, and 2 1/4. So that's 2 plus 1/4. Okay, and again, if I were to figure out the area, even though this isn't drawn proportionally, this is 2 and this is 1/4, they're not proportional, still if we can determine the amount of space in each one of those boxes and then add up all 4 boxes, we'll come up with the answer to our problem. Okay, so 3 times 2, well that's 6. 2/3 times 2. So let's record these over here. 3 times 2 equals 6. Let's go with 2 times 2 over 3. That just gives us 4 over 3. And 1/4 times 3. Okay. 3 times 1/4. That's simply 3/4. 3 over 4. And lastly, we have 1/4 times 2/3, and that's 2/12. And I'm going to leave it as 2/12 and not reduce it to 1/6, because then 12 becomes my common denominator when I need to add all 4 of these pieces up together. Okay, so that's what I'm going to do next. Okay, so I've got 6 as a whole number. Now here I've got 4 1/3. I can leave that and just record it as 4/3, or I can go ahead and change it now to 1 1/3. And to that I'm going to add 3/4 and 2/12. Again, I'm using 12 as my common denominator. You're always going to find it in the lower right-hand box. So this stays 2/12. To turn fourths into 12ths, I multiply by 3 over 3. And I get 9/12. To turn thirds into 12ths, I multiply by 4 over 4, and I get 4/12. And then I can just add these together. 4 plus 9 is 13, plus 2 is 15. I'll put my answer over here. So that's 15/12 is the fractional part, and 6 plus 1 is the whole number part. 7 and 15/12, but I know that 15/12 is 1 plus 3/12. Okay, so that's 12/12 plus 3 more 12ths gives me 15/12. So, oops, let's make that still our 7. So we take our 7 and we add the 1 whole to it that we got when we change this into a proper fraction, and that equals 8 and 3/12. And we can take the 3/12 now and reduce it, and that would give us 8 and 1/4. So that's using a graphic organizer or an area model that is not proportional to solve this type of a problem. There are other ways to do it, and I'm going to show you one here in just a second. So before I show you the next method, I want you to go back to our original problem when we just looked at a regular multiplication problem and we had a 2-digit by 2-digit. We came up with the 4 different answers. They represent each one of these boxes, and so this is just a different way of organizing that information. In this method, we're simply going to use a little acronym, and that acronym is FOIL, commonly referred to as the FOIL method. And what that stands for is first, outside, inside, and last. So again, if we break each of these up into their parts, we have 5 plus 1/2, and we're multiplying that by 1 plus 3/4. And to get our 4 amounts that we need from inside the box without drawing the diagram, all we have to remember is we multiply the first number in the first bracket by the first number in the second bracket. So there's our 5 times 1 is 5. Okay, And then we're going to go to the outside numbers. So we are going to go from the first number all the way to the left, and the last number all the way to the right, the two outside numbers. And if we multiply 5 times 3/4, 5 times 3 is 15 over 4. So to that we would add 15 over 4. Now we want to take a look at the inside numbers. So we're just going to go to these two right here, the two inner numbers. 1 times 1/2. So we have another answer of 1/2. And lastly, we want to do the last numbers. Okay, so those will be found right here, the last numbers in each bracket. 1/2 times 3/4, so that's 3 over 8. Okay, and again, all we have to do is add those pieces together. And once again, when we multiply the fraction by the fraction, that's going to give us our common denominator that we're going to need to easily add these all together. Okay, so let's change these into some easier numbers to add. So here I've still got my 5 wholes. Okay, and I've got 15 over 4. Well, that's 3 3/4. Okay, so let's just record that as 3 3/4 for now. Okay, and here I've got 1/2, and here I've got 3/8, and I'm going to use this number as my common denominator. So 3/8 remains 3/8. In order to get 1/2 into 8ths, I have to multiply by 4 over 4. So that gives me 4/8. And in order to get 4ths into 8ths, I multiply by 2 over 2, and that gives me 6/8. And when I add all these numbers together, there's 10, 13, 13/8, and my whole numbers add up to 8. And again, 13/8 is really 1 5/8. And I'm going to add my 8 wholes that I have to my 13/8, and that's going to give me a final answer of 9 5/8. So that's the FOIL method. Okay, and then the final method, and let's come up with a problem here. Let's do 4 2/5 times 3 1/3. There's a problem. And this is a method I call the OWL method. Okay, and that's simply because we're just going to use a little diagram, and I think it looks like an owl. So we're going to have to break down the two numbers again into their parts. Okay, so I'm going to draw 4 plus 2/5, and we're going to multiply that by 3 plus 1/3. Okay, and again, we're going to need to do first outside, inside, last, just like we did before. This just is kind of a graphic way of helping us to not leave out any of those pieces. So we know we have to do the inside. Okay, we know we have to do the outside. We know we have to do the first number, and we know we have to do the last number in each bracket. And to me, that just kind of resembles an owl. Okay, so again, all we got to do now is multiply those pieces. Here's where one answer goes. 2/5 times 3, that would be 6/5. 4 times 1/3, that would be 4/3. 4 times 3 gives me 12 wholes. And 2/5 times 1/3 gives me 2/15. And again, I'm multiplying the fraction by the fraction. So this number is always the one that's going to give me my common denominator. So now let's just add up the 1, 2, 3, 4 pieces. Okay, 12 whole. And let's do this one next. 6/5 is 1 1/5. 4/3 is 1 1/3, and 2/15. Okay, common denominator of 15. so that one just stays 15. This one, in order to get 1/3 into 15ths, I have to multiply by 5 over 5, and I get 5 over 15. This one I have to multiply by 3 over 3 to get it to 15ths, and I get 3 15ths. And I add these together, and I get 8, 9, 10. I add the whole pieces together, and I get 14. And my answer is 14 and 10 15ths, but that can be reduced because 10 15ths is 2/3. And there are your three methods.